Hello future engineers, welcome to my YouTube channel. If you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel to keep me refreshed, inspired, and going. And if you like my videos, if they are helpful to your studies, please don't forget to subscribe. For the given frame and loading shown below, the member HE has a uniform load of 24 kilonewtons per meter. So determine approximately the combined horizontal reaction at J due to gravity and lateral loads analyzed by the Portal method of approximate analysis. The approximate combined vertical reaction at J due to gravity and Portal method for the lateral loads. And letter C, the combined moment reaction at J due to gravity and lateral loads by the Portal method. So here is the figure. Take note that we have lateral loads. We'll first consider effects of gravity loads. So remember, HE is loaded with uniform load 24 kilonewtons per meter. So by Portal method, let's call this shear 1. This is 2 times V1, 2 times V1, and V1. So summation forces horizontal equals 0. For part A, 90 plus 150 equals 6 V1. V1 plus 4 plus 1, so 6 V1. So V sub 1 is equal to 40 kilonewtons. Then we can now analyze this part. So we have to solve VHE, which is WL over 2, where W is 24, length is 12, and this is the moment, 0.045 WL square. On the left side of H, we have VHL, or reaction at H at the left, and moment HL. At B, we have VVR and moment BR, shear BL left, and MBL, or reaction at the left of B, reaction to the right of B. Then we have 2V1, which is this by action reaction. So the distance is 2.5. So therefore, these are the reactions at J, horizontal, vertical, and moment. So let's just assume these are the directions. Gx obviously is to the left. Gy obviously is upward, and Mj is not yet sure if it is counterclockwise, but due to the lateral loads, it should be counterclockwise. And that's 2.25. So for Jx, it is equal to 2 times V1, and V1 is 40, therefore Jx is 80 kilonewtons leftward. Then for Jy, summation versus y equals, we have f of hj. F of hj, let's assume it is compression or downward, as shown, and plus vhr plus vh left plus vbr plus vb left. Actually, we can solve this shear left and right of these joints. So VHR equals WL over 2, 24 times 12 over 2, 144. VH left is 20 times 5 over 2, 50 kilonewtons. VB right is 9 times 12 over 2, so 54, and V sub B left is 9 times 5 over 2. So 22.5 kilonewtons. So our problem is FHJ by the Portal method due to these lateral loads. So let's draw the free body diagram of these portions here. And before that, let's solve for shear 2 to V2 and V2 by Portal method. So summation versus x equals 90, so 90 equals 6 V sub 2. So V sub 2 is 15 kilonewtons. So let's now have the free body diagram. This portion, green colored figures are distances or lengths, and so let's have 15 kilonewtons here, which is V sub 2 times 2, so 30 kilonewtons. So that this axial force, summation versus x, 90 minus 15 is 75 kilonewtons. And here we have the horizontal force, 90 or 75 minus 30, 45, or 90 minus 15 minus 30 is 45 kilonewtons. So call this FAG. Let's assume tension, but it is obviously tension. Call this force, axial force in VH due to lateral load, and that's 45. Shear is not important. So FAG, to solve for FAG, consider this free body diagram, summation moment about this point, which is AB equals 0. So counterclockwise moment FAG times 2.5 then equals 15 times 1.8. We sum up moment here. Although there is shear here, not yet solved, so let's solve for FAG first. So FAG is equal to 10.8 kilonewtons. So if FAG is 10.8 kilonewtons, summation versus y, so that's also 10.8. Action reaction, so that's 10.8. And let's call that shear in BC so that we can solve FBH later. So here we have shear V1 40, then this is 2 times V sub 1, so 80 kilonewtons. Then action reaction, we have 15, then we have shear here, that's 30. Then this force would be 15 plus 150, 165 minus 40, so that's 125 kilonewtons. Then here, that's not important because we plan to sum up moments about this point. So what is important here is the shear in GH. So call that FGL, GI. This is member GI, so FGI. So that's shear in GH, and they have force in HJ. Let's assume compression. So FAG is equal to 10.8 kilonewtons. That's why those are the values. Next is considering this free body diagram. Let's sum up moment about GH0. So FAG is 10.8. So FGI equals FGI times 2.5, summation moment here, equals 40, equals 10.8 FAG times 2.5 plus 15 times 1.8, this is 1.8, equal to that, 1.8, then plus 40 times 2.25. So FGI is equal to 57.6 kilonewtons. So for this slide, that's it for this slide. Let's continue this in the next slide. So let's continue and put the values we solved in the preceding slides. So these are now the values, and for the FBDs, these are the values calculated. So FBH was already solved. So shear GH therefore is summation versus y in this free body diagram. So VGH plus 10.8 equals 57.6. So shear GH is equal to 57.6 minus 10.8, and that is equal to 46.8, which is now shown here. So FBH, considering this free body diagram, summation moment about BC equals 0. So FBH times 6, that's 6 meters, half of 12, then plus 30 times 1.8, then equals 10.8 times 2.5 plus 6 is 8.5. So 10.8 times 8.5. Computing for FBH, FBH is equal to 6.3 kilonewtons. Then in this free body diagram, so let's have the 6.3. In this free body diagram, we can now solve FHA summation moment about HE equals 0. Clockwise positive, so FHJ times 6 plus 80 times 2.25 plus 30 times 1.8, this is 1.8, half of 3.6, then equals 46.8 times 8.5, 2.5 and 6, 8.5 plus 6.3 times 6. So we can now solve FHJ. It is equal to 33.6 kilonewtons. So another way of solving FGI and FHJ is we draw the FVD of this entire portion to shorten the solution. So this is another technique which you might apply in your analysis for this problem. So summation moment about GH, so that we don't need to solve for shear GH anymore in this situation. So this is also not needed because it passes through this point. So what is important is this 75 kilonewtons and that 90 kilonewtons. So FGI times 2.5, then counterclockwise plus 75 times 3.6, then equals 40 times 2.25 plus 90 times 3.6. So we can now compute FGI. FGI is 57.6 kilonewtons, so it verifies this answer here. Then another free body diagram for this entire portion, we sum up moment about HE. So these are the important forces. Remember shear 40 and 80. So this is no longer important. No longer important. So we sum up moment about HE equals 0. Clockwise positive. So FHJ times 6 plus 80 times 2.25. 80 plus 40 times 2.25. Same sense. Then plus 90 times 3.6, then equals 45 times 3.6 plus 57.6 times 5 plus 6, so 11. So solving for FHJ, it is also 33.6, so it's verified here. So there are two free body diagrams considering the detailed free body diagrams and the shorter, so that we can find these forces immediately. So now that we have found FHA, we can now solve JY. So GY equals FHA 33.6 plus 144 plus 50 plus 54 plus 22.5. So JY is equal to 304.1 kilonewtons upward. Finally, summation moment about J equals 0. So MJ counterclockwise positive plus MHL plus MBL equals MHR plus MBR. 2 plus 2 times V1 times 2.25. We almost forgot it. So MHR equals 0.045 times, remember the load on HE is 24 kilonewton per meter, and the length is 12. So it is 155.52 kilonewtons meter. MBR 9 kilonewton per meter, so 0.045 times 9 times 12 square, and it is equal to 58.32 kilonewtons meter. MHL loaded with 20 kilonewton load, and the length is 5, so 0.045 times 20 times 5 square, so it is equal to 22.50 kilonewton meter. Then MBL 0.045, the load is 9, so times 5 square is equal to 10.125 kilonewtons meter. Substitute into this equation, MJ plus 22.5 plus 10.125 equals 2V1, which is 80 times 2.25 plus 155.52 plus 58.32. Solving for MJ is positive, so the sense is correct, counterclockwise, 361.2 kilonewtons meter. So that's it for this problem.